Our solar system is a beautiful and intricate dance of celestial objects. Each planet, moon, and asteroid moves in a precise orbit, creating a cosmic ballet that has been ongoing for billions of years. The vastness of space is filled with these celestial dancers, each contributing to the harmony of our solar system. Planets, moons, asteroids, and comets all orbit around a single star, our Sun. The Sun, a massive ball of burning gas, provides the gravitational pull that keeps everything in place. Without the Sun's immense gravity, the planets would drift aimlessly into the void of space. The Sun's energy also fuels life on Earth, making it the most crucial element in our solar system. This intricate system, however, is not permanent. Over millions and billions of years, the positions and orbits of these celestial bodies will change. Stars are born, live out their lives, and eventually die, taking their planets and moons with them. Our Sun, too, will one day exhaust its fuel and transform into a red giant, engulfing the inner planets, including Earth. It is subject to the same laws of physics that govern the universe. These laws, such as gravity, electromagnetism, and nuclear forces, dictate the behavior of all matter and energy. They are the invisible threads that weave the fabric of the cosmos, ensuring that everything from the smallest atom to the largest galaxy follows a set of universal principles. Over time, these laws will bring about dramatic changes to our cosmic neighborhood. Stars will explode in supernovae, creating new elements and scattering them across space. Planets may collide or be ejected from their orbits. New stars and planetary systems will form from the remnants of old ones. The universe is in a constant state of flux, and our solar system is just one small part of this ever-changing cosmic tapestry. The Sun, the anchor of our solar system, won't shine forever. It has been burning brightly for about 4.6 billion years, providing the energy necessary for life on Earth. But like all stars, it has a finite lifespan. Like all stars, it has a life cycle. This cycle begins with the birth of a star from a cloud of gas and dust, known as a nebula. Over millions of years, gravity pulls this material together, forming a protostar. Currently, the Sun is in its main sequence, steadily fusing hydrogen into helium. This phase is the longest and most stable period in a star's life. In the Sun's core, temperatures reach millions of degrees, allowing nuclear fusion to occur. This process releases the energy that lights our world. The energy travels from the core to the surface and then radiates out into space, providing the warmth and light that sustain life on our planet. But in about 5 billion years, the Sun's hydrogen fuel will run low. When this happens, the Sun will leave its main sequence phase and enter the next stage of its life cycle. It will expand into a red giant, engulfing the inner planets, including possibly Earth. As a red giant, the Sun will be vastly larger and cooler than it is now. Its outer layers will be ejected into space, creating a beautiful planetary nebula. The core that remains will eventually cool and shrink into a white dwarf. This white dwarf will be a dense, dim remnant of the Sun, slowly fading over billions of years. Though it will no longer shine brightly, it will be a testament to the Sun's long and illustrious life. The life cycle of the Sun is a reminder of the dynamic and ever-changing nature of the universe. From its fiery birth to its quiet end, the Sun's journey is a fascinating story of transformation and endurance. As the Sun's hydrogen dwindles, its core will contract and heat up. This will cause the Sun's outer layers to expand dramatically, transforming it into a red giant. The Sun will swell to an enormous size, engulfing Mercury, Venus, and likely even Earth. Our planet will be scorched and lifeless. The outer planets, Jupiter, Saturn, Uranus, and Neptune, will experience dramatic changes as the Sun expands. The increased solar radiation will boil away their icy surfaces. However, their very survival is uncertain. Some models suggest they might be pushed outward, their orbits becoming unstable. A cooling ember, the white dwarf Sun. Imagine a star that has exhausted its nuclear fuel and is now a glowing remnant of its former self. This is the fate that awaits our Sun in the distant future. After its red giant phase, the Sun will shed its outer layers, creating a beautiful planetary nebula. This process will strip away the outer gaseous layers, leaving behind the core. This core, now exposed, is what we call a white dwarf. It is incredibly dense, with a mass comparable to the Sun's, but packed into a volume similar to that of Earth. This white dwarf will be much smaller than the Sun is today. Imagine compressing the Sun into a sphere the size of our planet. The result is a white dwarf, a stellar remnant that is both fascinating and mysterious. Unlike the Sun, which generates energy through nuclear fusion, a white dwarf no longer produces energy in this way. It has exhausted its nuclear fuel and is now a cooling remnant. It will slowly cool and fade over billions of years. As it cools, it will transition from a bright white to a dimmer, redder hue, eventually becoming a cold, dark, and inert black dwarf. This process takes so long that no black dwarfs are thought to exist yet in the universe. In the distant future, our solar system will be a very different place. The planets will continue to orbit the white dwarf, but the once vibrant and life-sustaining Sun will be a faint memory, a testament to the passage of cosmic time. The surface of a white dwarf is fascinating. It is thought to be covered in a crystalline form of carbon and oxygen, essentially a giant diamond in space. This crystalline structure is a result of the intense pressure and temperature within the white dwarf. Some white dwarfs are part of binary systems where they can interact with a companion star. In such cases, the white dwarf can accrete material from its companion, leading to fascinating phenomena such as novae and even potential type Ia supernovae. A type Ia supernova occurs when a white dwarf accumulates enough material to reach a critical mass, leading to a catastrophic explosion. This explosion is so bright that it can outshine an entire galaxy for a short period. White dwarfs are common in the universe and can be found in star clusters and throughout galaxies. They are the final evolutionary stage for the majority of stars, including our Sun. The story of a white dwarf is a reminder of the life cycle of stars and the ever-changing nature of the cosmos. From birth in a stellar nursery to the final stages as a white dwarf, stars undergo incredible transformations over billions of years. As we gaze up at the night sky, we are witnessing the various stages of stellar evolution. Each star has its own story, and the white dwarf is a poignant chapter in the grand narrative of the universe. The solar system's long goodbye. With the Sun as a white dwarf, our solar system will be a shadow of its former self. The inner planets will be gone. The outer planets, if they survive, will be frigid and desolate. The once vibrant solar system will become a cold and dark place. Drifting through the cosmos, a lonely future. Over trillions of years, the gravitational pull of passing stars will strip away any remaining planets or asteroids. The Sun will continue to cool, eventually becoming a black dwarf, a cold, invisible ember drifting through the vast emptiness of space. The fate of our solar system is intertwined with the fate of the universe itself. The universe is expanding, and this expansion is accelerating. This means that galaxies are moving farther and farther apart. While our solar system faces a finite future, the universe is filled with billions of other stars, many orbited by their own planets. Some of these planets might harbor life. The search for life beyond Earth is a testament to the enduring curiosity of humanity. The sheer vastness of the universe suggests that our story is just one of countless others. Life, in some form, may exist in other corners of the cosmos. This possibility fuels our imagination and drives us to explore the universe around us. The inevitable fate of our solar system reminds us of the preciousness of life and its fleeting nature, and the importance of appreciating our place in the cosmos, our home. While our time in this solar system is finite and ever-changing, our legacy as explorers and dreamers will live on forever.